So here in video 9, item A9 from the OWASP Top 10 2017 list, we have a non-mover using components with known vulnerabilities. And this has a grid which kind of says, well, exploitability is a little bit variable depending on what exactly the vulnerability is. So if you have a vulnerability in something like a public-facing web server, then it's likely to be more exploitable than a vulnerable component or library that's hidden below the surface that's not necessarily visible. And although this is very common, obviously not all vulnerabilities are as easy to exploit as others. And as I mentioned, detectability can vary depending on where exactly the vulnerability is. But possibly unsurprisingly, the technical impact of a vulnerability could be severe because we could be talking about remote code execution and full access to a certain machine or a certain application. So we've got a little bit of a mixed bag here depending on what exactly your application does and what it uses. Some of these exploits can only really be done manually, and although you do have automated tools, which we'll look at a bit later, that can help you find some of these vulnerable components, actually taking advantage of that is not always just hitting a button and taking advantage. There might be some extra work required to try and tailor or customize that attack for a particular system. So when we talk about components with known vulnerabilities, we've got some examples here, but a very classic example is we use a software library and we either don't keep up to date with any vulnerabilities that might be found in that library, or sometimes we don't even consider them right at the beginning. So we find a library to do a piece of functionality, let's say, for example, to deserialize an XML document. And if we don't have that built into our framework or built into the operating system, we find a library online, we use it, and we don't even consider that there might already be a known vulnerability. And very often that vulnerability might only include a very specific piece of functionality. So we might be able to switch these things off and disable stuff that we don't need. But if we use these libraries and we're not really keeping up to date with vulnerabilities, then we obviously put ourselves at risk. But a kind of a similar risk is when we use libraries from untrusted sources. And this can happen even if you're using a very popular framework. And it certainly happened to me in my mainly .NET experiences. You're looking for something very specific and you search for it, and you find there's only really one library that's any good or that seems to be fairly functional. So you might take that library without really thinking about who's written this library. Is it somebody who knows how to write a secure piece of software? Is it from even a foreign government or something that could have questionable motives? So we can use libraries without really thinking about the risk that we introduce. But maybe a more kind of well-known scenario is using server software or components like your Apache web server, like IIS, like Nginx, like anything else. And especially since a lot of functionality might be enabled by default when we install these systems. So we're vulnerable not just to things that we're actually using and that we know that we're using, but we're also vulnerable to systems that just happen to be turned on and we haven't switched them off. And again, it all comes back to knowing what versions of software we're using and whether they have known vulnerabilities. And then, in some ways this can apply to anything really, any component that you haven't specifically written. It could refer to database engines, operating systems, any other components that we use outside of our main application are all potential risks. And obviously some of them are easier to take advantage of than others. So anything that faces the public internet is going to be more vulnerable in most cases than something like an operating system or a database engine, which is generally going to be protected by other systems. So we do need to consider more than just libraries and our server software. And in general, this is an issue when we have no process for monitoring and updating our components, our libraries, our server software. Then we're vulnerable by definition, because anything can have a vulnerability that gets discovered after the software's been released. And so often we just don't have any kind of view of this in any consistent way. So we might have a good view of our main application, but what about our business applications? Or, what about systems we don't use very much but are still there, they're still visible to the internet, and they're still vulnerable. So anytime we don't have a process in place for regularly keeping on top of this, then we're vulnerable. Now, in terms of how common it is, we could probably say that pretty much every system that you will work on has a vulnerability somewhere in one or more of the components, because not only does it exist in many places, like we mentioned earlier, databases or web servers or libraries or components, or even online services, but that said, they won't all be exploitable. So you might have, let's say, a vulnerability in your database engine, but because that piece of functionality is not used in your application, then there would be no way for an attacker to actually get to that piece of vulnerability to exploit it. So not all vulnerabilities are equal. It will depend very much on your application and how much functionality is exposed, how much is blocked off, how much is disabled, because we've got such a wide spectrum here, from very obvious, very detectable, very easy to exploit vulnerabilities right through to vulnerabilities that are largely impossible to take advantage of. And I just want to show a couple of examples really of how easy these things can be discovered. And the first one is a search engine called Showdown, and it's primarily designed for finding Internet of Things devices. And I'll show you another example in a second, but this is actually a page that's linked from the OWASP top 10 document. So if you want to find this link, you can find it there. And it's a historical report taken from 2016, so 2 years ago, 3 years ago nearly, about devices that are vulnerable to the Heartbleed vulnerability. So this was a major vulnerability. You can see there at CVE 2014-0160. And Heartbleed was basically a way to take advantage of SSL encryption and potentially to hijack the encrypted data. And you can see that in 2016, when this report was made, there was still, nearly 60,000 sites that Showdown found that were vulnerable just in the United States alone. And even in other countries, we're talking about loads of sites, probably very often sites that were forgotten about, or maybe they were set up 5 years ago and they're not actively maintained, but still you can see the amount of vulnerability just from one single issue. And this is purely from a search engine. And what Showdown's often used for is to search for things like webcam. And then you can see here it kind of searches various countries, it searches information, and you can see some of these. Look, it's managed to ping something called a webcam. This one's in the United Kingdom in Marlborough, and you can open this in another tab. I'm not going to do it because I don't know I don't know what's there, although that's a Raspberry Pi, so it's probably nothing terrible. But it's as easy as this to find public information on services that are running on the public internet. So that's one example of how an attacker might look for something very specific. So that report we were looking at is actually a type of search where you can search for a vulnerability specifically. And then what Showdown will do is it will find versions of web servers or whatever that it knows to be vulnerable, and it will return that in the results. So you do have to register if you want to use vulnerability searching, but obviously if you were a criminal or whatever, you would probably pay that money to get the power of Showdown and other tools. So that's kind of one example. Another example is basically a scanning tool. So there are several, there are probably 10 or 20 fairly widely used vulnerability scanning tools. And these are tools that are more likely to be used on an internal network or as part of a formal pen test. So we could look across multiple machines, across subnets. We could be looking inside a company network. So we could say, well, let's ignore the firewall for now. Let's assume we're inside. Are we still vulnerable inside? Because as we know, people are often very good at putting strong firewalls in place for external attacks, but don't necessarily consider the types of attacks that could come from inside the network. One of these is OpenVAS, which is a suite of tools made by a company called Greenbone. And I'm just going to show you an example of this. This is a Kali Linux VM that I'm running on my host machine. And if I just log into here, now, I've already run a vulnerability scan on the host machine. So this is the virtual machine, and I've run this against the host, which that's my internal IP address there, 192.168.56.1. And as I've scanned this, it's only found a single vulnerability, which is probably not very surprising. I have a fairly simple desktop machine, obviously not running hundreds of services. But even here, it's already found one, what it considers a medium risk. And if I click on this report, it's going to make me log in again. Try and get my password. Page, log in. You can see it's listing a vulnerability, which is effectively RPC enumeration. And what this is a port where you can go to a Windows machine and kind of say what distributed COM operations are running on this machine, and it will tell you what they all are. So it's not necessarily a terrible vulnerability. In this case, this would only be visible from my internal network anyway. And, in this case, it might tell me, oh, there's a, printer service running and stuff like that. If that was a problem, of course, I could close this port down on the firewall, run the scan again and make sure it's not vulnerable. But these can take a significant amount of time because they're searching through lots of vulnerabilities, lots of pieces of software. We're talking about thousands of entries. So what will often happen is people will set these up and maybe leave them running overnight, especially if they're running against an entire network. And of course, in an enterprise situation, you could have hundreds of desktop machines and servers, and it might only be one or two of them that are running some unexpected software or some old versions that a tool like this can pick up on and can show you what's going on. So that's kind of the way a professional pen tester would approach vulnerability scanning. And so when we talk about fixing it, I mean, really, we're talking about knowing that there are vulnerabilities and keeping up to date. So the very first one, we've seen it several times now in the top 10, remove anything that you don't need. So if you've got components in your application and you're not sure what they're for, you should be able to fairly easily find out whether you can just remove them and see whether your application still builds and runs. Obviously, depending on your application, that might be easy or not. Same with any kind of dependencies on external services, on external servers. It might be some of these things that you could say, well, actually, we only really need that to be wired up when we're running a backup, for example. So maybe we could leave it disabled most of the time and only switch it on for backup. So removing the attack surface obviously always makes things better. And then using tooling to automate version management. Now, this is a massive subject and it's certainly not something I have a lot of expertise in. But depending on whether you're kind of a Windows company or a Linux or Mac company, there are different ways, different tools that you can buy that will effectively give you a network-wide view of what's running where in terms of versions of particularly web servers, any public accessible services like publicly visible databases. And when I say publicly, I mean visible on the network rather than just an internal service on a single machine. So you could use tooling like that, which obviously you have to pay for most of that, but it's giving you that picture, that insight of saying not only is stuff out of date, because you kind of probably want to know that as well, but also to know if any of the versions of software you're using, certainly the ones that are visible to a scanning tool, are vulnerable. And of course, it doesn't work against things like software libraries, because the versions of software libraries are not visible generally to the kind of the public network, but you could consider perhaps a health check page on your applications, which could perhaps produce a JSON piece of JSON data, which your scanning tools might be able to consume, just to then say, right, you're using this version of Apache, this version of .NET or whatever it might be. So using the tooling really is the kind of the big one here to automate this as much as possible. Obviously, you should try and only use legitimate libraries. So there's obviously a trust issue when you use anything from a third party. You can never be completely sure, but if you use libraries, components, services from a vendor, especially one that you're paying for, there's a better chance that you're getting a commercial deal and not just somebody trying to sell a library that has vulnerabilities in it, or somebody who's, glued something together in their spare time, but which doesn't work very well and which is going to cause a security problem for you later on. So the more legitimate you can use, the better. And, we've got to get used to paying for things, paying for quality. You can get good stuff for free, but you can't always get what you need for free. So sometimes we need to pay to get that level of trust. We then need to have a policy and a process for unmaintained components. I mean, if you've got something there that's an old library that's not maintained anymore, what are you going to do about that? Because you're not going to be able to patch something that's not being maintained. And probably more importantly, you're possibly not going to know about any vulnerabilities that exist in that, because in general, it's going to be the maintainers of a component that are likely to be aware of vulnerabilities, because usually they would be told by anybody who discovers a vulnerability. So you could have a policy or process that says, we're not going to use unmaintained components, or we're going to, hide them from the public internet. Or the next point here is you can deploy additional controls. So you could say, well, although this component of my web server isn't maintained anymore, if I put another firewall in front of my web server that has some extra functionality, I might be able to filter the types of attack data that's actually going to take advantage of the vulnerability. So by adding additional controls, additional levels of depth, then I might be able to mitigate some of the risk from things that I can't patch. We've mentioned this before as well in terms of vulnerable components. If you've got something that needs to carry out an action on the operating system or do something maybe a little bit more privileged, consider using sandboxing. So using a virtual machine, using another machine, another server, to try and keep the risky part of the operation away from the rest of the application, or away from the database, or away from the rest of the network. So at least then if somebody does take advantage, you're exposing the minimum amount of data that you can. And for example, if somebody takes over your sandboxed machine, then they're not going to be able to see a database, because there's going to be no connection there to the database server. So you might be able to do something with that depending on what you're doing. Another one is about consistency. So particularly as soon as your company is more than about 10 or 20 people, the number of pieces of equipment that you have just starts going up, in a crazy fashion. Some large enterprises probably have, 5 machines for every employee they have. So you could be talking about thousands and thousands of desktops and servers and telephone exchanges and security systems, any other special equipment, SCADA systems, IoT, all of these things that are all sitting on a network somewhere. So having consistency makes your life easier. And one example of using that is having continuous deployment of your production systems, so that when you push a new deployment, you know that the versions of Apache are the same, the versions of .NET, of PHP, whatever it is you're using are always the same. So then when you need to make an update, you only need to update one script in your CD system, and then you know that all environments from that point onwards are going to be using the new version. But the same also goes for every other system that you deploy. How are you going to keep that consistency? How are you going to make sure that you don't deploy an old version of PHP because you haven't gone back to that server and touched it for 5 years? So there's lots of this is process, lots of it is tooling. It's all going to be fairly complicated and probably worth sending somebody on some decent training for, just to make sure that you've got that visibility. And another maybe more modern way of mitigating the risk is to consider transferring the risk to software as a service, so that you don't have to maintain underlying operating systems or versions of software. So, for example, if you run Redis cache on your own machine, you've got to maintain the operating system, you've got to maintain the version of Redis and any other dependencies it has. If you were to use, say, Azure Redis or AWS Redis, then it's up to the cloud provider to manage the OS and its updates, and it's up to them to manage the version of Redis and all its dependencies. So you get to transfer the risk to somebody who's probably set up better than you are to manage those versions and to avoid those vulnerabilities. So nothing really, again, very specific we can say here. This is quite a general topic, quite a general thing to consider, but probably this is going to be one of the more complicated and long-winded implementations for you, because it is going to consist of tooling of different people in different departments in charge of different parts of your overall infrastructure, and all of the kind of the subtleties and details involved there. But as with all of these, don't be put off by the amount of work. Having something is better than having nothing. If 90% of your infrastructure is brilliant and you can't really deal with the other 10%, then that's better than not dealing with all of it. So, try by starting and doing something. You'll soon learn the ways in which this stuff works and doesn't work. So that's it for A9. Again, a reminder, please read the top 10 publication. Some of the links that I've used are in that. Some of the cheat sheets and the explanations and everything are all in there. Search for OWASP top 10 on your favorite search engine and you'll find hopefully what you need to find out. Any questions or comments, please chuck them on the video below. Otherwise, I will see you in the next video.